The first paradox, time travels. This is where things get terrifyingly complicated. Imagine you've built a time machine. Your mission is simple: travel back to prevent a historical tragedy. But here's where logic starts eating itself alive. Let's say you succeed in your mission and prevent that tragedy from ever happening. If the tragedy never occurred, then you would have no reason to build a time machine in the first place. But if you never built the time machine, you couldn't have traveled back to prevent the tragedy. So the tragedy happens, which gives you the motivation to build the time machine, which allows you to prevent the tragedy, which removes your motivation to build the machine. You're trapped in an infinite loop of contradiction where cause and effect become meaningless. Every solution creates the very problem it was meant to solve. This isn't just a clever thought experiment. It reveals something profound about the nature of causality itself. If time travel to the past is possible, then our entire understanding of cause and effect might be fundamentally broken. Scientists have proposed several escape routes from this logical nightmare. Some suggest the universe is self-correcting, that reality itself would conspire to prevent you from creating paradoxes. Your time machine would malfunction at the crucial moment. You'd slip on a conveniently placed obstacle. The universe would literally bend the laws of physics to maintain consistency. Others propose an even more unsettling solution. Every time you change the past, you don't erase the original timeline. Instead, you create an entirely new parallel universe. You become a temporal refugee, forever stranded in an alternate reality that you created but can never escape. Your original timeline still exists somewhere, but you'll never see it again. The implications are staggering. If this is how reality actually works, then every decision you've ever made might have created countless parallel versions of yourself, living completely different lives. Right now, there could be infinite versions of you, watching infinite versions of this video in infinite parallel universes. This paradox doesn't just question whether time travel is possible. It forces us to confront whether our actions have any real meaning if every possible outcome happens somewhere in the multiverse. Moving from time to space, our second paradox reveals something equally disturbing about our place in the universe. Look up at the night sky and count the stars. Our galaxy alone contains hundreds of billions of them. The observable universe contains trillions of galaxies. The numbers are so vast they become meaningless to the human mind. With all those stars and all those planets orbiting them, basic probability suggests that intelligent life should be everywhere. The universe has existed for nearly 14 billion years. Even if intelligent civilizations developed slowly, they should have had more than enough time to spread across entire galaxies. Advanced aliens should have left traces of their existence that we could detect today. And yet when we point our most sensitive instruments toward the heavens, we hear nothing but silence. No radio signals from distant civilizations. No massive engineering projects around distant stars. No signs of interstellar travel or colonization. The cosmos appears to be utterly, profoundly empty of intelligence other than our own. This silence is more than just disappointing. It's deeply unsettling because it suggests one of several terrifying possibilities. Perhaps we are truly alone in the universe, the only conscious beings to have ever emerged from billions of years of cosmic evolution. The odds against this are astronomical, but if it's true, then we carry an unimaginable responsibility as the universe's only witnesses. Or perhaps intelligent life is common, but something always destroys it before it can spread to the stars. Maybe every civilization eventually develops technology that outpaces its wisdom, leading to nuclear war, environmental collapse, or artificial intelligence that turns against its creators. If this is true, then we are approaching the same deadly filter that has eliminated every other intelligent species in the galaxy. There's an even darker possibility. Maybe the universe is full of intelligent life, but they're all hiding from each other. In a cosmos where advanced civilizations might view any other intelligence as a potential threat, Broadcasting your existence could be an invitation for annihilation. The silence we hear might not be emptiness but fear. Each explanation for this cosmic quiet reveals something different about the nature of intelligence, technology, and survival in the universe. None of the answers are comforting, and all of them suggest that our existence might be far more precarious than we realize. Our third paradox brings us back to Earth, but challenges something even more fundamental than our place in the universe. It questions why we can see anything at all. This might sound absurd, but it reveals one of the most important discoveries in all of cosmology. Here's a simple question that stumped astronomers for centuries. Why is the night sky dark? If the universe were infinite in size and age, filled with an infinite number of stars, then every single point in the night sky should be occupied by starlight. No matter where you looked, your line of sight would eventually hit the surface of a star somewhere in the infinite cosmos. The entire night sky should blaze as bright as the surface of our sun. There should be no darkness anywhere, no distinction between day and night. Every moment should be seared by the combined light of infinite stars. But obviously, this isn't the case. We have darkness. We have night. This simple observation completely contradicts the idea of an infinite, eternal, and static universe. The solution to this paradox revolutionized our understanding of reality itself. The universe is not infinite in age. It had a beginning approximately 14 billion years ago in what we call the Big Bang. This means we can only see light from stars whose photons have had enough time to travel across space and reach us. Light from more distant stars is still on its way, leaving their patches of sky dark. Even more importantly, the universe is not static. Space itself is expanding, and this expansion is accelerating. As the fabric of space-time stretches, it stretches the wavelengths of light traveling through it. Light from the most distant galaxies is stretched so much that it shifts out of the visible spectrum entirely. Their light still reaches us, but we can't see it with our eyes. This paradox revealed that the darkness between stars is actually evidence of cosmic history. Every patch of dark sky tells the story of the universe's beginning and its ongoing expansion. The night sky isn't empty. It's full of invisible light from galaxies so distant and so ancient that their photons have been stretched beyond recognition. The darkness we see is the ghost of the Big Bang and the shadow of cosmic expansion. What seems like empty space is actually teeming with information about the birth and evolution of everything we know. These first three paradoxes have already shown us that our intuitions about time, space, and even basic observation might be completely wrong. But we're just getting started. The remaining paradoxes will challenge even more fundamental assumptions about the nature of reality itself. The fourth paradox takes us into the bizarre realm where the very small meets the very large, and common sense goes to die. This paradox involves a cat, a box, and a piece of radioactive material. But don't worry, no actual cats were harmed in the making of this thought experiment. Picture this scenario. You place a cat inside a sealed box, along with a small amount of radioactive material. The setup includes a detector that has exactly a 50% chance of registering atomic decay within 1 hour. If decay occurs, the detector triggers a mechanism that releases poison, killing the cat. If no decay happens, the cat remains alive and well. Now here's where reality starts to break down. According to quantum mechanics, before anyone opens the box to check, the radioactive atom exists in what scientists call superposition. It's simultaneously decayed and not decayed, existing in both states at once until someone observes it. But since the cat's fate is tied to the atom's behavior, this means the cat must also be in superposition. The cat is both completely alive and completely dead at the exact same time. Not mostly dead, not barely alive, but genuinely existing in both states simultaneously until the moment someone opens the box and forces reality to choose. The act of observation doesn't just reveal the cat's condition, it actually creates that condition. This paradox wasn't created because scientists enjoy tormenting imaginary cats. It was designed to show how absurd our quantum mechanical understanding of reality becomes when applied to everyday objects. At the subatomic level, particles routinely exist in multiple states simultaneously. But when does this quantum weirdness stop applying? Why don't we see everyday objects existing in superposition? Some interpretations suggest that every time a quantum measurement occurs, the universe splits into multiple parallel realities. In one reality, the cat lives. In another, it dies. Both outcomes happen, but in separate universes that can never interact with each other. This means every quantum event creates countless new realities, and we're constantly branching into an infinite multiverse of possibilities. The implications are staggering. If this interpretation is correct, then there are infinite versions of you right now, experiencing every possible variation of your life across parallel universes. Some versions made different career choices. Others never existed at all. The paradox forces us to question whether there's only one reality or whether reality itself is constantly multiplying. Our fifth paradox involves two identical people and reveals that time itself is far more flexible than we realize. Imagine twin siblings, perfectly matched in every way. One stays on Earth living a normal life, while the other becomes an astronaut and embarks on a journey to a distant star at nearly the speed of light. According to Einstein's theories, something extraordinary happens during this journey. Time passes differently for objects moving at extreme speeds. For the traveling twin, time slows down dramatically compared to everyone back on Earth. What feels like a few years of travel time for the astronaut corresponds to decades passing on Earth. When the space-traveling twin returns home, they discover their Earthbound sibling has aged much more rapidly. The traveler might have aged only 5 years, while their twin aged 50 years. The traveling twin has effectively journeyed into the future, arriving at a time when everyone they knew has grown old or died. But here's where the paradox emerges. From the perspective of the traveling twin, they were stationary inside their spacecraft, while Earth zoomed away at incredible speed and then returned. If all motion is relative, shouldn't the Earthbound twin be the one who ages more slowly? Both twins see the other as the one moving at high speed, so both should expect the other to age less rapidly. This creates an apparent contradiction until you examine what breaks the symmetry between the twins. The key difference is acceleration. The Earthbound twin remains in essentially the same reference frame throughout the entire experiment, but the traveling twin must accelerate to reach high speed, decelerate and reverse direction at the distant star, then accelerate again to return to Earth. This acceleration makes all the difference. It's the twin who changes reference frames, who experiences the forces of acceleration, who will always be younger upon return. There's no contradiction, just a demonstration that our everyday experience of time as universal and absolute is completely wrong. The paradox reveals that time is not a constant background against which events occur. Time is dynamic, flexible, and intimately connected to motion and gravity. What we think of as simultaneous events in different locations might actually occur at different times depending on how fast you're moving when you observe them. Moving from the very fast to the very slow, our sixth paradox involves an ancient Greek philosopher who argued that all motion is impossible. His reasoning was so compelling that it puzzled mathematicians for over 2,000 years, and the solution revealed something profound about the nature of infinity itself. Consider the simple act of walking across a room. To reach the far wall, you must first travel halfway across. But to cover that remaining distance, you must first travel half of what remains, which is a quarter of the total distance. Then you must cover half of that quarter, which is an eighth of the total, then a 16th, then a 32nd, and so on forever. The problem is that you can divide any distance infinitely. No matter how small the remaining distance becomes, you can always cut it in half again. This means that to cross the room, you must complete an infinite number of smaller journeys. You must pass through an infinite number of points in space. But how can anyone complete an infinite number of tasks in a finite amount of time? The same logic applies to any moving object. A race car trying to reach the finish line must first reach the halfway point, then 3/4 of the way, then 7/8, and so on through an infinite sequence of positions. By this reasoning, the car should never reach the finish line because it can never complete an infinite number of movements. This paradox reveals a fundamental disconnect between our intuitive understanding of space and motion and the mathematical reality underlying these concepts. The solution, which took, lies in understanding over 2 millennia to develop fully that infinite series can have finite sums. Yes, crossing the room involves an infinite number of steps, but these steps become progressively smaller at exactly the right rate. When you add up all the distances, 1/2 plus 1/4 plus 1/8 and so on, the total equals exactly one complete room length. Similarly, the time required for each step becomes infinitely small, and the total time is finite. The paradox doesn't prove that motion is impossible. It proves that our everyday intuition about infinity is completely wrong. Reality operates according to mathematical principles that often contradict common sense, and our universe runs on the logic of advanced mathematics, whether we understand it or not. These paradoxes are starting to paint a picture of reality that's far stranger than anything we experience in daily life. Time is flexible, particles exist in multiple states simultaneously, and infinite processes can have finite results. But the remaining paradoxes reveal even deeper problems with our understanding of existence itself. The 7th paradox involves information, and it threatens to break physics entirely. This paradox emerges when 2 of our most successful scientific theories, which work perfectly in their own domains, are forced to coexist in the same extreme environment. Black holes represent the ultimate victory of gravity over all other forces in the universe. These cosmic monsters have such intense gravitational fields that nothing can escape once it crosses a boundary called the event horizon. Not matter, not energy, not even light itself. Whatever falls into a black hole is gone forever, cut off from the rest of the universe. But quantum mechanics tells us something that seems to contradict this picture entirely. One of the fundamental principles of quantum theory is that information can never be truly destroyed. You can burn a book, but the information about every atom in that book still exists, encoded in the smoke, ash, and heat produced by the fire. You can scramble information beyond recognition, but the universe never allows it to disappear completely. So what happens when you throw that book into a black hole? According to general relativity, the information crosses the event horizon and becomes permanently inaccessible to the outside universe. It's gone forever. But quantum mechanics insists this is impossible. Information cannot simply vanish from existence. The paradox deepens when we consider that black holes aren't completely black. They slowly leak radiation over enormous periods of time, eventually evaporating completely after trillions of years. When the black hole finally disappears, what happened to all the information that fell into it? If the information is destroyed, quantum mechanics is wrong. If the information somehow escapes, then black holes aren't the perfect prisons that general relativity describes. This isn't just an academic debate. It represents a fundamental crisis in our understanding of reality. 2 of our most successful theories are giving contradictory answers about the fate of information in the universe. The resolution of this paradox will likely require a complete revolution in how we think about space, time, gravity, and information itself. Some proposed solutions are mind-bending. One possibility is that information never actually falls into the black hole, but gets encoded on its surface in ways we don't yet understand. Another suggestion is that our entire three-dimensional reality might be a holographic projection of information stored on distant, two-dimensional surfaces. The paradox might be telling us that our perception of solid, three-dimensional space is actually an illusion. The eighth paradox reveals something even more disturbing about the fundamental nature of observation itself. This isn't just about quantum mechanics or black holes. It's about whether the act of looking at something can fundamentally change what that something actually is. At first glance, this seems like common sense. If you want to study how teenagers behave naturally, you hide cameras around a school. But the moment they notice they're being watched, everything changes. They become self-conscious, they perform for the cameras, they act differently than they would in private. Your observation has contaminated the very thing you wanted to measure. But when we descend into the realm of atoms and subatomic particles, this contamination becomes something far more profound and terrifying. It's not about psychology or self-consciousness. It's woven into the fabric of reality itself. Consider an electron, one of the basic building blocks of matter. Before you try to measure it, this particle doesn't exist as a tiny ball sitting in a specific location. Instead, it exists as what physicists call a wave function, a ghostly cloud of probability that represents all the places the electron could possibly be found. The electron isn't hiding somewhere specific within this cloud. It genuinely exists in all those locations simultaneously. The moment you try to pin down exactly where the electron is, everything changes. To detect its location, you must bounce light off it or interact with it in some way. But this interaction forces the probability cloud to collapse instantly. The electron is suddenly compelled to choose a single, definite position from all its possible locations. Your observation didn't reveal where the electron was. Your observation created where the electron is. Before measurement, there was no definite answer to the question of the electron's location. After measurement, there is. Reality itself is participating in a dance with observation. And we're not just passive spectators. We're active participants in determining what becomes real. This leads to a principle that sounds like it belongs in philosophy rather than physics. There are fundamental limits to how much you can know about reality at any given moment. The more precisely you measure one property of a particle, the less precisely you can know about other properties. It's not because our instruments are crude or our techniques are inadequate. It's because reality itself has built-in uncertainty. The implications are staggering. This suggests that at the most fundamental level, the universe doesn't have definite properties just waiting to be discovered. Instead, properties come into existence through the act of measurement. Reality is not a fixed stage on which events play out. Reality is a collaborative process between the observer and the observed. What counts as observation becomes a crucial question. Does it require a conscious mind? Or does any interaction with the environment trigger the collapse from possibility to actuality? The boundary between the quantum world of probability and the classical world of definite outcomes remains one of the deepest mysteries in all of science. Our ninth paradox takes us beyond the microscopic realm and challenges the very nature of existence on the grandest possible scale. This paradox doesn't just question individual particles or black holes. It questions whether anything we experience is genuinely real. Here's the logic that keeps philosophers awake at night. Assume that civilizations can survive long computing technology. Assume they enough to develop incredibly powerful, become interested in running detailed simulations of their own history, perhaps to understand their past, or for entertainment. These simulations would need to be sophisticated enough to include conscious beings, simulated minds that experience their artificial reality as completely genuine. Now consider the numbers. A single advanced civilization could potentially run thousands, millions, or even billions of these historical simulations. Each simulation might contain billions of conscious minds living entire lifetimes, falling in love, creating art, experiencing joy and suffering, completely unaware that their entire universe is composed of computational processes. If this scenario is possible, then the number of simulated conscious beings would vastly outnumber the biological beings living in base reality. For every real person, there might be millions or billions of simulated people living in artificial worlds. Here's where the paradox becomes personal and terrifying. If simulated minds vastly outnumber real minds, then any randomly selected conscious being is far more likely to be simulated than real. This includes you. This includes your memories, your experiences, your entire life story. The mathematics are coldly logical. If conscious simulations are possible, and if advanced civilizations create them in large numbers, then most conscious beings must be simulated. You might think these words with your biological, your reading eyes in a physical universe, but you could actually be a pattern of information processing in some post-human computer, experiencing an artificial reality so convincing that you cannot distinguish it from the genuine article. This creates three equally unsettling possibilities. Either intelligent civilizations always destroy themselves before reaching simulation-capable technology, or they reach that technology but choose never to use it for ethical or practical reasons, or we are almost certainly living in a simulation right now. Each option reveals something disturbing about the nature of intelligence, technology, and survival in the universe. The first suggests we face inevitable extinction. The second suggests that consciousness might be considered too precious or too dangerous to simulate. The third suggests that everything you've ever experienced might be artificial. The most unsettling aspect is that a perfect simulation would be indistinguishable from reality by definition. There might be no way to prove food would still taste genuine, whether you're real or simulated. The relationships would still matter, achievements would still feel meaningful, but the nagging possibility would always remain that everything is computational. Our final paradox brings together everything we've learned and reveals the ultimate problem with reality itself. This paradox suggests that the very act of trying to understand the universe might be fundamentally impossible, not because we lack intelligence or technology, but because understanding and reality might be incompatible concepts. Throughout human history, we've assumed that objective reality exists independently of our observations, and that science gradually reveals the true nature of this reality. We've believed that the universe operates according to fixed laws that we can discover through careful experimentation and logical reasoning. But the paradoxes we've explored suggest something far more troubling. Reality might not be objective plays a crucial role in determining it all. The quantum realm reveals that observation, what becomes real. The simulation hypothesis suggests that our entire universe might be artificial. Time paradoxes indicate that causality itself might be an illusion. Each time we probe deeper into the nature of reality, we discover that being. Each time we try to step, reality depends on the act of outside the system to observe it objectively. We find that we're inescapably part of the system we're trying to understand. We cannot separate the observer from the observed, the question from the answer, the scientist from the experiment. This creates an infinite regress of uncertainty. If our observations shape reality, how can we trust our observations to reveal what reality is actually like? If we're potentially simulated beings, how can we trust our simulated instruments to measure a simulated universe? If time and causality are illusions, how can we trust logical reasoning that depends on cause and effect? The paradox suggests that complete understanding of reality might be logically impossible, not because reality is too complex, but because the very concept of understanding assumes a separation between knower and known that doesn't actually exist. We are not outside observers studying an external universe. We are integral parts of the universe trying to understand itself. This doesn't mean science is worthless or that we should abandon the quest for knowledge. It means that every answer we discover reveals new questions, every solution creates new mysteries, and every attempt to map reality changes the territory we're trying to map. The ultimate paradox of reality is that reality itself might be paradoxical. The universe might be fundamentally self-referential, self-modifying, and self-questioning. We are patterns of matter and energy that have become complex enough to wonder about our own existence. But this wondering might change the very thing we're wondering about. These 10 paradoxes haven't just challenged our understanding of specific phenomena. They've revealed that our most basic assumptions about existence, knowledge, time, space, and consciousness might be fundamentally flawed. The solid, predictable, objective reality we think we inhabit might be nothing more than a persistent illusion created by the limitations of our perspective. The universe doesn't just contain mysteries. The universe might be mystery itself, an ongoing question that creates new questions with every attempt to answer it. And perhaps that's exactly as it should be. A completely understood universe might be a dead universe, while a mysterious universe is one that remains eternally alive with possibility. The cracks in reality run deeper than these paradoxes might initially suggest. What we've discovered isn't just that our understanding is incomplete, but that incompleteness might be the fundamental nature of existence itself. Every time we think we've found solid ground, the universe reveals another layer of uncertainty beneath our feet. Consider what happens when you try to step outside these paradoxes and examine them objectively. You quickly realize that you can't. You're trapped inside the very system you're trying to analyze. When quantum mechanics tells us that observation changes reality, we can't observe this process without participating in it. When the simulation hypothesis suggests we might be artificial, we can't test this theory without using potentially artificial instruments and potentially artificial logic. This creates a hall of mirrors effect, where every attempt to find truth reflects back on itself. We're like characters in a story, trying to determine whether they're fictional, using tools and reasoning that would themselves be fictional if the hypothesis were correct. The very concepts we use to think about reality, causality, time, space, and existence might be artifacts of whatever system we're embedded within. But here's where things become even stranger. These paradoxes don't exist in isolation. They're interconnected in ways that suggest something profound about the architecture of reality itself. The observer effect in quantum mechanics relates directly to the information paradox of black holes. Time travel paradoxes connect to questions about the nature of causality in a potentially simulated universe. The silence of the cosmos might be explained by civilizations hiding from each other, or by the possibility that most conscious beings exist in simulated realities rather than the base universe. Each paradox amplifies the others, creating a resonance effect that makes reality itself seem unstable. It's as if the universe is constructed from contradictions, held together by the tension between opposing truths that cannot coexist yet somehow do. The more precisely we examine any aspect of existence, the more paradoxical it becomes. Perhaps most unsettling is what these paradoxes reveal about the nature of knowledge itself. We've built our entire scientific method on the assumption that objective truth exists and can be discovered through careful observation and logical reasoning. But if observation changes what we're observing, if logic leads to contradictions, and if reasoning might be occurring within a simulated system, then the foundations of knowledge become quicksand. These 10 paradoxes reveal something that should shake you to your core. Reality isn't just mysterious, it's fundamentally unstable. Every assumption you've made about existence might be wrong. Time might be an illusion, your observations might create what you think you're discovering, and you might be nothing more than information processing in some advanced computer. The universe isn't hiding its secrets from us. It's showing us that secrets might be all there is. What you call reality could be the ultimate paradox, a question that changes every time you try to answer it.